All right, good morning. Let me see how many of you online. Kyla, Melody, and Blake. So this is today's attendance question. I was pulling this out of the actuarial science exam question and see if we're able to calculate the answer from this. This is one of the questions from section 3.5 about deferred annuity. So here we have N payment is an annual payment of 1,000, 200,000, a million and 200,000 payment per year for the payment of 15 million. Okay, so the whole idea is that the first payment is due in 3 years after the loan is taken out. So we want to find out what is the amount of the drop payment. The one we're calling drop payment is in fact the payment after the 1 year after the ends payment, right? So obviously the actual number payment will be N plus 1, N payment plus last payment. And in this case, we do not know how many payment will pay all those total amounts. So what I have in mind will be roughly find out N has to be at what level. And with different N, we can calculate its value, its present value to match the amount of the loan. Whichever N give us a slightly higher than the loan amount will be the N we're using. Then with that N, we're able to determine how much is left after the ends payment, the less the payment after that will be the last payment. So anyway, let's try to think about the timeline. And then what I was doing on the board is try to figure out, since the question gave us annual effective discount rate, that also means we do not have the interest rate immediately given. I have to figure out a way to calculate the actual annual effective interest rate. What I was writing on the board is the relation between the discount rate and the interest rate. Essentially, the discount rate is discount to the present time. So if you want to find out the future time, you have to divide the discount rate. So 1 minus d to the power negative t is the amount a year later, which is the value for 1 plus I. So I was writing down that equation in order to figure out the I. I did the calculation for 1 minus 0.0055 to the power negative 1 minus 1. That's a reverse calculation from the formula of 1 plus I, calculate I minus 1 outside the left side equation. It turns out to be not a very short number. It would be looks like it's going to be a repeated decimal. So whichever one that's easier to enter in the calculation, we'll use that one as our I. And we know the amount per year. Let's try to make it slightly easier for computation. This looks like the payment is 15 million. So each payment was roughly 1.2 million. So we can consider paying 1.2 each time. How many do we have to pay to reach 15, right? So then the following number 0 really doesn't matter. What matters is really the increment. So what we can do is calculate if we're paying 1.2. Oh, it's deferred payment. So our first payment does not occur at time 0. It's like this. This is the time 0. The first payment is due in 3 years after the loan is taken out. So this is where the loan is taken out. And 1, 2, 3. This is the first payment. 2, assuming that L, the loan amount is 50 million. That's 1.2 million. Okay, so that was planned. So if we're depending on what formula are we using, let's say the final amount is reached here 1.2. Okay, and then we're paying n of them. So then if you start with 3, the last payment will occur at, if we do 3 to If we do 3 to 9, we pay 7 payment. So if we pay n payment, it's actually n plus 2. Three to 9 is 7 payment, right? The differences between. So I think the largest payment will be at n plus 2. All right, and then of course we are really trying to find what will be the last payment, the draw payment. We have one more payment after that. So if we think about it, this is the initial time here. This will be your, if you have a 1.2 payment of, and then the value at this point will be annuity immediate. That's assuming your first payment coming one period after this. At this point, your value would be 1.2 times AN. Actually, we wish to reach it to be higher than this, right? So I guess just AN plus 1, but it really doesn't matter. This 1.2 AN should be lower than the total amount, right? So then that also means that 1.2 times AN plus 1 will become higher than the 15, right? We're trying to look for the target total loan amount to be higher than the 1. Actually, not the 15. 15 is at time 0. By the time you reach at time 2, it's already 15 times 1 plus I to the power 2, because you have to consider the interest rate. This is a deferred payment, deferred for a 3-time period. So at time 2, your total loan balance is now 1.5, 15 times 1.5 to the power 2. And then all of your future payment would have this the value between these two, right? 1.2 AN will be too low, 1.2 AN plus 1 will be too high. We okay there? So we don't know exactly what is the value of N. That will be the problem in this case. You can use your calculator to calculate this faster, but we're going to use a calculator, not the financial calculator, regular calculator. Let me see when can we reach high enough. The first thing is we also have to calculate the total value, and our target value is not going to be, it's actually 15 times. It's 15 times 1 plus I squared, because we have to allow it to grow for 1 time period. We have the I right here, but for that I find the decimal a little bit hard to write in, so we would do 15 times 0.945 to the -1 power and then -1. So I'm using that one as my I, but then you have to do I plus 1, so that is so -1. And this one is raised to the power 2. So that's a 15 1 plus I. Are we okay with it? Is it okay? So I don't want to use this I. This is 0.0582010582. That is the accurate number. That's why I keep the long decimal. Instead, I want to use a 1 minus 0.005 to the -1 power -1 as my I. And then we're going to calculate I plus 1. So then the -1 is canceled. So we got I plus 1 equal to the 1 minus d to the -1 power. There's the 1 minus d to the -1 power. And then we raise it to the power 2, which essentially is raising it to the power of -2 for the method. So we can actually do it this way, -2 power. That's when we square the 1 plus I. This will give us like a target value for your annuity, and then using that we will be able to find out the proper N. Once you have the N, okay, so that's what we have. It's actually slightly higher than, okay, this is slightly higher than 15 million. It's like Then 16 million, that's 2 years after the investment. And then a year later, we have our first payment. We're using an annuity immediate formula. That's assuming the payment it's 1 year after time 2. So we're going to try to calculate this to find the proper n. Which n is probably, we're probably going to start somewhere high. And you can do a quick calculation to do the total loan amount is a little over 16. What was it? 16. Let's do 17. So if we do 17 divided by, was it 1.2? We can do 17 divided by 1.2 to roughly say every payment is 1.2 million. Try to reach 17 million. How many? That we got 14. Are we okay there? So we're going to start with n equal to 14 to say n 14 reach the target. So if n, the number payment is 14, and we're calculating this annuity value and the present value for the annuity. So we're going to do 1.2 multiplied by an when n equal to 14. So what's an? An is 1 minus the 1 minus the 1 plus I reached to the power 14 and divided by I. That's the annuity, it's negative 14. Right, that's the AN formula, right, for A. And then remember what's our I. We had a talk about the I. I is calculated from the discount rate. We have that 1 plus I is equal to 1 plus I is equal to 1 minus D to the negative power. What's 1 minus D is 1 minus 0.055. So 0.945, that's the 1 minus D. And to the negative 1 power, you can do 1 over 0.5. So that's what our 1 plus I. So this 1 plus I is that number, and then 1 plus I to the negative power is now the 0. Okay, so negative 1, and then this is going to be 0.945. So that's 1 plus I to the negative power, and we reach this to 14. Are we okay there? All right, and then the denominator is supposed to be I, and then we have to kind of see where the I is supposed to be. And here we're going to write the I formula. The I is going to be 0.945 to the negative power. That's 1 plus I. And then we have to minus 1 to get the I. And that's pretty much the A14. And I want to see how that value is, whether it's lower or higher than the 16 million. 0.79. Right, so let's see. So this is really my approach for it, and then that's way lower than expected. So we realized that maybe when we are doing the calculation of the size and we didn't consider the interest rate. So that's way lower. We're looking for somewhere close to the 16.79, right? So we know we were supposed to reach the end, but once we have a calculation plan, it's not hard to change it. So we can go way higher. Let's do 17 payment to see what that is. All we have to do is read the same calculation, the calculator, and moving this over to 17. You can see how it's been growing too. So small. Only 12. Okay, I was like, that's sweet. So then maybe 27. Okay, so if n equal to 27, then the payment is close to 16. So you can see in this question, we do not know how many payments. That's why I have to try approach to get to a close enough end value. So maybe 30 payments. If we're paying a lot. So we can see that if we have 30 payments and 30, we are reaching to a high enough payment. And then I need to know if N29 would be the lower one, right? We want to know one more, one more, and we want to know if that solved the problem. 29. And that's not a low, that's still like, that's lower, right? So, that's so we did achieve what we wanted. If n equal to 30, it would be too high. If n equal to 29, it would be too low. So we know that we were supposed to be paying 29 payment. So back to the question that we have here. The this is using different payment sides to figure out what's the number of payment that we were supposed to be paying. So it looks like we're paying 29 payment of the 1.2 billion. Paying it for 29 years. Now, what's the last payment? That will be the question. All right, so what we figure out right now is the value at time 2. So at time 2, if you are paying, if you are paying 29 payment, we're gonna try to find out the remaining portion of the payment. We intended to pay this much, right? That's what we wanted to pay, and then if you pay 29 payment, this is what we end up paying. We actually paid, subtract them. Right, that is the difference will be the value at time 2, the difference between these two payments. We're getting this much. So that's the value at time 2, with the unit being a million. Right, we need to find out its future value because it's paid after n payment, right? In this case, our n is supposed to be 29. That's the one that we're actually using, n equals 29 payment. So 29 payment later. So we're finding its future value. So we should multiply this with a interest rate to get value. It's reached to, this is the payment after the 29 payment. So I think the power should be 30, right? 1 plus I to the power 30. That's 1 plus I to the power 30. Now what's 1 plus I? That's our 1 plus I. The 1 plus I, so we're replacing the 1 plus I by using the discount factor for its computation. And that should be it. It should be the value. And of course, we want to convert it to a million. So we multiply this by the 10 to the 6th power time 1. 10 to the 6th power multiplied by million. That's what we have. Hope that kind of makes sense. That's at least that's what I get. Right, and then we're going to compare with the choices. A little bit off. Did I mess up the power? Let me see if it's 29. What happened? So 30 is not. All right, I think this is the right answer. I think what happened here is a rounding error. What I calculated, as you can see, I try not to do any rounding at all. I was using the exact number. But I guess with the actual payment, you have to do some rounding when you are trying to determine your value of the payment. The answer to the question, if I have a system. Do you have any question? I hope that kind of makes sense. I'm trying to go over this question from the annuity formula that we learned. This question do also have a deferred payment. So we're reaching out to this amount because before the first payment is value is at time 2. That's why I increased from 15 to 50 times 1 plus I to the power 2. I hope I didn't make any calculation error in the process. But that's the target value. And I did a couple of annuity present value calculation to figure out what would be the value at time 2, just to reach the time 2 value of the loan amount. Any question? Right, to me, I think the solution should be the last one from the calculation that we just did. But if I made a mistake, feel free to mention that we can actually correct our reasoning. Most of the calculation is over here. That was the line, the timeline in the numerical calculation. We tried to use different n so that we did an n for this and for this to find the perfect n to offer one below, one higher for that n, determine the n. Once we did those, did a couple calculations, 14, so 27, 30, and 29. 30 is too high, 29 is low. That's why we realized 29 will be the n, and find the differences between the two. We did the calculation. We're aiming for 29 and the target loan. That difference is the last payment. And you can see the 2A looks like a B. B looks like this amount, but we have to look for the time value. That's why we have to multiply the bigger number to reach it. Yeah. Okay. Let me post up the scanner so you can enter your answer. You should have your clicker link. If you don't have it, I can send it over to you. I have Melody's solution. Link and Tyler, do you still have your link? Anthony and Tyler, let me plug your link. Sorry that my approach seems to be kind of time consuming, but I think the idea is clear. The time part is on my part. It's B. I tend to use mathematical formula and our calculator. Taylor, that's your clicker link. Now we should be able to answer the continuous question. Tyler, are you online? See, Anthony has submitted the answer. The answer is D. And that's what it is in the system. So I think, at least in the question bank, it was D. My rounding, I can't guarantee the rounding. I was using the discount factor, not using my I. I calculated I value. If you round the I value, or if you rounded your payment, that there will be some rounding error. But the answer should be B. Right, so that's today's attendance. Answer to the question is D. Let's talk about the test 1. We're gonna have test 1 over chapter 1 and 2, the equation of value for any given time, and also the interest rate calculation with compound interest or simple interest. There'll also be question about dollar-weighted average yield rate calculation or time-weighted yield rate. I didn't really put a time-weighted yield rate calculation, but it's one of the fund performance. There are 5 questions that will be on the actual exam, so I'm thinking that could be also the objective of these 2 chapters. I posted a solution set online for test 1. I wonder how prepared you guys for it, because we are going to have tests. So I hope most of you are ready for it. So, and this is a test 1 sample. Pretty much this is for the floated rate calculation and yield rate calculation. And there are questions about calculation the interest rate or interest calculation for the forced interest using the forced interest to calculate the accumulation function. So you have to download the Word file to see the forced interest function. There are quite a few questions that already appear when we are doing the bigger question in class. So I was using the question that we've done in the past as the test sample question. And I think I also posted a solution video. That was the video explaining the solution for all the 12 questions posted. I wonder if you had a time to take a look and what would be your comment? Like, do you think you will be ready for the test one Thursday? Any comment? Was taking test one on Thursday okay for your progress, or have you done all your assignment on Webwork for your test for chapter 1 and 2? We're gonna take test 1 either this week. Even if we push it to next week, it won't be any later than next week because the midterm is due next Friday. So I'm hoping to have at least one test in the class. So I kind of see where we are. Any comments for the tests? Yes.
Questions in study said be pretty similar.
Yes. Should be pretty similar to the test, or it should be similar to the homework question. So I either pull those questions up I either pull those questions from the study guide or from the online Webwork homework for the test question. Let me know it will be okay. What you will be allowed for the test, you can use a formula card and your calculator. It's we don't have statistics in this class, so we are relying on formula on our calculator. Yes, I can reopen the homework for review before the exam. Anthony, do you mean we move it to the next Tuesday instead of this Thursday? What do you mean by Thursday or Tuesday? Because it is this Thursday. So your intention with that comment, yeah. So you wish to move it to a later date than this Thursday. Is that what you mean? Okay. All right. This class has only 6 students. Right now, the attending is 4 students. So based on the decision with what you guys thinking about. I can definitely reopen the chapter 1 and chapter 2 homework for you to study. But you know what, work never get closed. So even if it's closed, you can still see the question. You can still answer the question to check if it's right or not. What do you think about the timing? So Anthony, you mean next Tuesday? All right. Do you think you will be more prepared if it's next Tuesday? Not trying not to surprise anyone that the test is coming up. I also want to give you enough time to study. All right. Yeah, Kyler and Melody, what do you think? Yeah, it's Blake. Blake said it's either way, either day is okay. So I really I don't hear any strong opinion right now about the timing. The point is you gotta finish all your homework, and if we don't finish the homework, we don't have that sense like how the equation value will be set up. Melanie said she'll be okay taking it next Tuesday because she's sick this week due to COVID. So more time would be better. Okay. So it looks like everyone is fine either way. But in spirit of giving more time, let's make it next Tuesday. I'll change the date to next Tuesday. That means you have to study during the weekend because often if we don't study before the test date, a longer weekend actually is not helpful. But being a Tuesday means on Monday, you know what's coming. So it's a little bit better than Mondays. Tuesday always is better than Monday since Monday is normally not a day when we're sitting around. Me, I personally don't get anything done during the weekend, so I always will be a little bit cautious with weekend because sometimes over the weekend we have a different lifestyle compared to the regular weekdays, which we always study and work. But anyway, let's try to be prepared and let me try to change the dates so everyone would know the test is moved. So let me change that. That means it's gonna be March 4th. You should have your LinkedIn. So that's that for that test. In the meantime, what we were originally planning for today was going over where we start. There's one thing today. There's an undergraduate panel. I don't know if you guys have any plan for graduate school or ever consider it. But it will be an informational session. I also offer extra credit for it. It's tonight at 6 p.m. in People's Room 112. They said there will be pizza and water at 5:30. So if you're around the campus by 6 or 5 p.m. tonight, feel free to attend, and they will probably offer more information about graduate school if that's one of the options. I also am thinking about getting my own kid to go to graduate school since she's a little bit introverted. I don't feel like she's not ready for work yet, so they maybe go to school for a few more years will be beneficial when she's more mature. So one way or the other, I think graduate school is one of the options. If you're not yet ready for professional field and you have no specific career plan, then graduate school is the option to try to go there and listen whether those opinion or information is helpful for you. And then again, actual credit, right? Just want to announce that. What we're gonna do today, I remember I posted the test one review problem, solution for the test one review. Hopefully, you can share your notes with me. If there's any typo in there, feel free to let me know. Time for last time. We're talking about chapter 3. Chapter 3 work on annuity. 3.2 is annuity immediate, 3.3 is annuity due, 3.1 is perpetuity when the payment is infinite money payment given time. 3.5 is the one we are working on, which have a deferred, which means you delay the first payment for a couple of time frame. And from 3.5, we hope to be able to calculate value total cash flow at any given time, not just before the first payment, after the payment, or in the middle of the payment. With those being in mind, if we were talking about outstanding loan balance, I think I might have updated that file. So we're going to continue with 3.6 today. If we're not having the test, I'm going to try to ask you guys to try to get ready for the test by looking over those solutions. This is not allowing to download. I have ever since tried to update what I was writing. All right, we were starting to talk about outstanding loan balance, that you borrow some money and you start paying it back. So this section focuses on outstanding balance. Basically, is how much money still needs to be paid for a loan that was borrowed. So this is where I'm trying to change here and there. A little L represent the loan amount originated. N is number payment in the loan payment plan. And the outstanding loan balance is to find out how much money still needs to be paid. So theoretically speaking, there's two methods. One method to calculate outstanding loan balance is called retrospective method. That is what you're going to do is you find out how much money do you owe minus how much money you paid, and the rest will be the outstanding loan balance. But in the process, we have to realize the impact of interest. So L is the money borrowed, but by the time K, you got to find out what the value of L at time K. So L is multiplied by 1 plus I to the power K. That's finding out that at time K value of the L. L is the value at time 0. So at time K, the L is now L times 1 plus I to the power K. Now, Q is a payment that we made in the past. Every payment is the value of Q. Let's say you already paid K payment. Now, at time K, the total value will be an ending value or a cumulative value. So here we're going to find out the cumulative value of all those K payment of Q. So the subtraction offer a outstanding loan balance calculation using the past information. Another plan of calculating the outstanding balance is using the future payment. And there's two formula offered here, depending on whether the Q has been consistently the same payment. One payment plan is you're paying the same amount. You're paying Q amount, you have already paid a K. K payment is done. So how many payment left is N minus K. N is total number of payments, so N minus K is the payment remaining. So Q times A and K is the present value of all your future payment. Now, on the other hand, if your last payment ended up being a little shorter than the regular payment, this is a more common case because our loan balance normally don't equal to the same value of the end payment of Q. So let's say you paid N minus 1 and then the last payment is a little less. We're calling the last payment as R. R will be the remaining portion of the loan balance. So then this is why there's two payments. One is assuming the last payment is a little less. One is assuming the last payment is the same. Any question? Okay. So we worked through a few examples already last time. The first example having payment of 80, it's being paid every month. for the next 30 months. And we have the monthly interest rate of 0.4%. The question is to find the loan balance immediately after 2012's payment. So then we're calculating OLB at 12. OLB 12 is what we intended to calculate. So that means we paid it 12 times of those $80. So what do? This situation is we are clear that we're paying 30 payment of 80. Therefore, we are not clear about the loan balance, the originator loan. So which means we don't know how much did we borrow, but we know how much we have to pay in the future. So the balance is easily calculated using the future. If you're clear about the future, using the prospective method. If you're clear about the past, using the retrospective. In reality, actually, we should be clear about both, but when you are looking at a question, we only have to show the information. So this will be the kind of situation. We don't have the L, we don't have the loan amount, but we have all those following payment. We still need to pay 18 more of the payment. So the calculation will be, we were supposed to calculate 80 times, this is a calculation of A12. A12 is a present value of 18. That's supposed to be A18. I'm sorry, that's my error. Is in the past there's 12 payment, but in the future it's prospective method. That was supposed to be A18. That was a typo. That's why you see it's 1 minus 1 plus I to the negative 18 power. The calculation has a right number. It's 18, not 12. But then we end up having like outstanding loan balance of 1,386.7. Any question? This was one that we talked about before, and then that's the timeline. They pay the 12 and still need to pay 18. The original loan is not given. So at the bottom row, it's the calculation that was in the book. So you can see it's the same as I was doing with my calculator. It's a 13 minus 12, it's 18. All right, the second example has a different scenario. We have a loan amount originated as 20,000 and we're paying 2,500 at the end of the year. So it's not a monthly payment, it's actually an annual payment. The last payment is supposed to be a little bit smaller, which means that we really are not clear about the future since we're not given the last payment amount. In this question, we're clear about what happened in the past. We have the loan amount, we have the payment in the past. So we're trying to find out the outstanding loan balance just after we have made the total of payment of 15,000. So this will be the question that if you paid 15,000, every payment is 2,500. That is 15 divided by 2.5. That's pretty much 6 payments. So that is right after the 6 payment. What would be the balance? This will be the calculation. So the number payment is 6. We're supposed to calculate OBL6. Given a retrospective method calculation OBL6, it will be 20,000 times 1.08 to the power 6. Since we're calculating times 6 value, so the loan amount is being raised to a higher value at times 6. And then the 2,500 multiplied by S6, since it's a cumulative value instead of present value. Right. So that I write my own calculation down. So I did figure out what would be the K. So K equal to 6. That's why we need to calculate OBL6 based on the fact that past is clear. So those are from calculation. It's the same solution as here. I just write home steps with the computation. All right, moving forward, the next question is about home mortgage. All right, so let's say we buy a home for $256,000. Right now we have a mortgage. The down payment is 40,000. So we're gonna take away the 256 minus 40. That's the loan. So the down payment you pay with your cash, and then the rest is all financed. So that the loan amount will be the subtraction of those big number. The interest rate is 6.5. The hopper sell their home at the end of the 8th year. So this is a the thing with mortgage, people don't really keep paying the mortgage until they finish. It's a long time, 30 years is a long time. A lot could change. In this case, they decided to sell the home at the end of the 8th year. So you can see this a little slightly more complicated situation than before. Just after May, their 96 end of the month's payment. If they're paying per month, 96 payment divided by 12, that's 8th year. That's exactly a year. All right, so the outstanding balance will be OBL 96 in that case, since they're end of month payment. The sales price is 286. Obviously, it's higher than the original selling price, right? And the differences between the home price, they made a little bit of money by the time A. Most of the home have an increased value. That's why sometimes people like to do real estate business because it does make money. All right, they choose to, their closing cost is 3% of the selling price. So you take the selling price minus multiply by 3%. Those are the money they have to pay. The outstanding balance is just deducted from the amount they receive. So even though they earn some money from selling their home and they still have to pay the rest, right? They can only sell the home when the home is theirs. Now, because they sell the home, they have the money to pay off the rest of the outstanding balance, right? Then they can now have home, and then the home is there to sell. All right. Now they have the money, and the other side, the side that purchased the house had the home. Right, and the bank have the interest. That's what happened. How large a check do the Hoppers receive, and how much interest did they pay over the 8 years? So the calculation is obviously the check will equal to the sales price minus the closing cost minus the outstanding balance, right? So if you want to know how much money do they receive, you're gonna have to find out the outstanding balance. So here, let's try to analyze on the timeline from 0 to 30 years. Their annual interest rate is 0.065. According to the question, the I is 6% annual interest rate, and they are paying per month. So we need to know what will be the monthly interest rate calculation. So upfront, when you read the question, you have to collect information. In the question, identify key information. So the number payment is 96. So if you're trying to find the check will be sales minus closing cost minus the outstanding balance at 96. So if we find out the outstanding balance at 96, the rest is straightforward for the computation. And then if you want to find OBL 96, you have to know the proper interest rate monthly. Right now, we only have the annual interest rates. We have to do a little bit of interest rate conversion. There. So moving forward from there, we know we have our loan amount, which would be the subtraction, and the L equal to this, L equal to 216,000. Now, we are saying to pay by 30 payment, and there's no mention about what is exactly each payment. So we don't know the Q. So here we're gonna have to find out every payment. Q is equal to the lower amount is happened at 0. So we have to use the present value, which is the A formula. So we will do L divided by A 360. Every year is a monthly payment. Every year have 12 months, 30 year. That's 12 times 30, 360 payment. So L divided by A 360, which will allow us to calculate the Q. Now, why do we have to know the Q? Because we need to find out. And here is my calculation for the Q, which ended up being 1,338.96. We have to kind of round it to 2 decimal numbers of their payment. Now we need to know the Q because we need to calculate the outstanding loan balance. In this case, we have the original loan amount, so maybe the retrospective way is better for the outstanding loan balance calculation. So here we are. To calculate outstanding loan balance at 96 months, you calculate what is the loan amount is L. And then 8 years later, you have your annual interest rate 1 plus I raised to the power 8. Okay? And then plus the 96 payments, their total value at time 8 year, time 8, 96 payment later. So we're gonna do a few accumulation value. It's S, not A, because it's value at 8. So here we have is the 1 plus I to the power 96. Actually, this is supposed to be, 96 payment, right? 1 plus I to the power 96 minus 1 over the I. Now the I has to be the monthly interest rate. That's the I calculation over here. I is say 1.065 to the power 1 over 12. The I has to be a monthly interest rate. Let's be clear with that. Any question? Now we have our balance. Once we have the balance, then we're going to go back to the check calculation of the check amount. The check will equal to sales minus closing costs minus the outstanding balance. The sales is 286,000. The closing cost is 3% of the sales amount, and outstanding balance we just finished calculation it, and that will be actual check that the family will receive. Any question? So it's still quite a amount of money, and so now the last question. So obviously we realized they did pay a lot to the bank. So how much interest did they pay? The interest is the payment that they paid, which include the original money and then the interest. So the actual payment we have, payment is the same payment Q times 96. They paid 96 payment of 1,338.96. Those are the total number payment. And then the change in their balance. They originally owed 216,000. That was a loan amount. Now, by the time they reach T8, their outstanding balance is the outstanding balance is what is it? 190,800.24. If you subtract these two, that's how much they reduce in their balance. So they are being credited for the change in their balance is what they're being credited for. And that means they actually pay a lot after those are going to be considered as interest. Any question? Okay, so you can see the payment are not paying the 216,000 for that only, and they actually paid a lot as the actual payment with their own interest. Any question? Interest sometimes is something we are concerned and we need to know. We know for sure we're paying a lot of interest, but we really don't have a way to avoid that if we're paying over a long time period. Okay, what we observe from that question is can see the amount of interest paid over a period may be calculated by first determining the difference between the outstanding balance at the beginning of the period and at the end of the period. In our case, we take the original loan balance multiplied by minus by the ending balance. That's what we end of the change in the balance. So then at the bottom, the subtraction in the parentheses is the change in the balance. And that's not the interest amount, but that's going to determine the interest calculation. All right, and then that's the amount of principal paid. The principal that we paid is what's actually impacting the balance, but the amount of interest paid is obtained by subtracting the amount of principal paid from the total amount payment. So many of our payment is paid toward the principal. Some of the paid interest payment is paid toward the interest. What I heard is that when we're paying the mortgage, the first one, like the first couple of years, most of the money are paid for the interest. That's basically how the bank is setting it up. Okay. All right. Okay. We have time. Now this example is talking about missed payment, and that happened with mortgage or with car loan, any kind of loan. Occasionally we miss a payment because we're careless, occasionally because we're tight on budget. So anyway, if there's any missed payment, how we calculate the balance? So here it says Waswade took out a 16 months car loan with an interest rate of 3% convertible monthly. To repay the loan, Washwade was to make monthly payment of 252.65. During the first 3 years of the loan, he made all the payment as scheduled, except that he neglected to pay the 14th and 30th. What's the outstanding balance at the end of the year, just after he made the payment schedule at that time? The end of the 3 year, if we're paying a monthly payment, end of the 3 year, which would be 12 times 3, 36 payments. We're talking about outstanding balance at 36 times equal to 36 payment. Now, just want to be more clear about it. So here is saying that we got a car loan for 16 months, right? The title says first section, so called 16 months, 16 months, 12 months in a year, 60 divided by 12, that would be 5 years. So we know it's a loan for 5 years. So, so you have, was writing the Q, there's a lot of Q, so at every time point, we're supposed to have the payment of Q. But then we have 0 at 14 and 60. So we suppose this person forget to pay it at time 14 and time 30. And then we're trying to figure out what will be the outstanding balance. All right. Any questions so far? Supposedly, if you did pay the 36 payment, all 36, what's leftover payment? 60 minus 36 is 24. I was writing down the leftover of the payment. So how do we calculate the kind of balance? I think it's easier to, we don't have the loan amount, as you can see. It's a loan 16 months loan payment for 5 years. And we don't have the originated loan amount, but we know the future payment is 252.65. So now we kind of see what would be the future. So this will be the situation where the future is very clear and the past is not so clear. We know we missed the payment. So how do we fix the past? We don't have that plan. What we can expect is there is more payment to come. Right, originally, if all the 36 payment is paid, then 16 minus 36, 24. There's 24 payments still has to pay in the future. And then there are 2 payments in the past that was skipped, and we have to add that onto our balance, right? Right? So any missed payment that we didn't do will be added onto the balance. So this is what happened. All right, the 3% interest rate is convertible monthly. We divide it by 12 to get our interest rate. And then the outstanding balance at 36 will be calculated by future payment, 24 payment of 252.65. We're finding its value at times 36. So compared to the future payment, 36 is a present value. Okay, and then so 252.65 times 824, the value for the future payment plus those 2 payments that we didn't do, we gotta calculate their present value. That means we have a value of 252.65 at 14, at time 14. Move forward to time 16. You have to, between 14 and 16, how many payment? It will be 12 payment. 36 minus 14 is 12. So we have to multiply by 1.0. This is actually 1 plus I to the power 12. Same thing to the times 30 payment. Between 30 and 36, the difference is 6 months. So the monthly interest rate 1 plus I raised to the power 6. So those are the value that we calculated for the time 36. At time 36, all the future value is being presented or discounted onto time 36. All the past payment that we didn't do are now forward in time by multiply by 1 plus I to the second power to get the total value. That will be the calculation for the outstanding balance. Any question? So that's another way to look at things. because the past is not clear since the loan amount is not given. We're using the future for the computation. But if there's any missing payment in the past, they're being counted, like added onto the total balance. But when we're adding the total balance, we have to consider the interest rate as well. So we probably paying way more since the interest rate is added, right? So definitely going to increase the balance because of this payment. That would be this example. All right, this example is talking about varying interest rate. Suppose a loan is to be repaid by 20, end of the quarter payment of 1,000. The interest rate for the first 2 years is 6% convertible quarterly, and then for the last 3 years is 8% convertible quarterly. All right, so interest rate increase, how would that affect our balance? Find the loan balance just after the 6 payments and the outstanding balance immediately after the 15th payment. So we're calculating 2 of the loan balance. They will be a little bit different in either cases. All right, this is assuming the interest rate has been negotiated. The change of interest rate is already to be understood or agreed on. All right, so if you look at the whole setting, the cash of the payment is always Q equal to 1,000. And then between the year, the time 0 to time 8 being 8 quarterly. The quarterly payment, I think it's quarterly payment. They're compound quarterly. So quarterly payment, the I4 is a quarterly interest rate. You have to divide it by 4 to get the quarterly interest rate. That will be per interest rate per payment period. All right, and then so between 0 year and 2 year interest rate is 6% quarterly, and then from time 2 year to 5 year interest rate is 8%. I'm trying to draw everything that's already considered here. Now this layout is displaying all the information that's given in the question, but you want to organize it in the way so it's easier to follow with our formula. Any question? Okay, so how do we exactly calculate it? We want to find OB6 and our file 6 over here. And again, this will be the situation. It's very clear how much payment is coming in the future, but not so clear about the loan balance. In this question, the loan balance is not given. If you want to calculate the loan balance, you have to calculate all the future value and determine their time 0 value. That should be your loan balance. Since that's not a question, we don't have to go ahead and do it. So that also determine that our loan balance calculation will be based on all the future value. So it's going to be a prospective method, right? So let's see how we calculate this. Oh, it looks like we did calculate the loan balance. Oh, the loan balance was one of the questions. I understand now. So find the loan amount. So we do have to calculate the loan balance. The loan balance will be all the present value for all your future cash flow. So for example, the 1,000 payment in the first 2 years is 1,000 multiplied by 8. There are 8 payment for the interest rate of 0.015. So that is clear enough. But then after that, it's still 1,000 payment, but there are 12 payments to come. And those 12 payments will be using interest rate of 0.02 because the annual interest rate is 0.08. Then we have to stop. So those are 1,000 times 812 is calculating the value of all the future payment at time 8. Now from time 8 to time 0, you have to use a different interest rate. So then you are discounting and using 1.015 to the negative 8 power to get their total value. Any question? All right, the second one is outstanding balance at time 6. It's a time 6 value. If you look at time 6, there are 2 payments to come, right? And then 2 payments that's with the interest rate 0.0015, and there are 12 payments with 0.02 interest rate. So basically, we're counting all the present value of the future payment. 2 payments in one interest rate, and there are 12 payments with the other interest rate. The calculation for the loan balance and the OBL6 is very similar. You always have to consider the 2 different scenarios. one with a lower interest rate, one with a higher interest rate. Any question? Feel free to use your speaker if you have any questions. The last question will be the outstanding balance at 15. But 15 is OBL 15 is right in the middle of here. That's after you made 15 payment of Q. The total number payment is 20. If you already paid 15, you only have five payment left. Those 5 payment always interest rate of 2% per quarter. And therefore, we don't want to consider the lower interest rate anymore because they're past that age. And we're only looking at the future. The remaining 5 payments are always the same interest rate. So it's 1,000 times A5 with 0.05 interest. So outstanding balance at 15 is slightly easier than the loan balance or outstanding balance at an earlier time. Any question? So that would be that example explaining using the A formula to calculate the balance. This is also 3.6. This is not the first time we're going to talk about loans, and we're actually having more about the loan balance in chapter 6. So then there's more topic about it. This is the first introduction where we talk about loan balance, and also occasionally we also talk about the interest, and then it will be more topic in that sense in the future. Any question? Right, I hope that gives us some idea on how those annuity formula is being applied on different scenario. Sorry, I try to go over what we have already done a little last time, and I got a few minutes left. So let me go over and start one more thing on this topic. 3.6 is focused on outstanding loan balance. The whole chapter 3 focuses on different way where the annuity formula is being applied on solving a more extensive question. Talk a little bit about 3.7. Because, well, whenever I can go a little bit forward in the progress, I'm trying to go over them a little by little. Because every session I try to review, so almost review it 8 times. Right, 3.7 called non-level payment. So far, all the payment plan for the loan, we're talking about paying the same amount. That's the one we call a Q. But that's not always the case. Sometimes we pay a little bit more here, but a little bit less there. But as long as there are any pattern involved in the whole payment plan, we want to know their present value, and we want to know their cumulative value in the future. So this 3.7 handle that kind of situation. 3.8, I'm putting them all 3 together, is when the payment have geometric progression. So let's say you pay 10 and then 10 times 1.5 and then 10 times 1.5 times 1.5. So if it's in the geometric geometric fashion with all the payment, that's what we handle in 3.8. 3.9 is talking about annuity with payment in arithmetic progression, like 10, 20, 30, 40. So that will be 3.9. We're talking about that situation when the payment are not level, not the same anymore. How do we do it? The answer is we still are trying to find pattern and formula to handle that kind of situation. What's the difference between those 3? 3.9 actually have its individual notation. So it gets a little more complicated with arithmetic. 3.7, we're still using annuity notation, annuity formula. We're just looking at the different tricky way to combine them. So 2.7 is not much different from all the previous session. 3.8, we'll have to review geometric sequence and how do we use geometric summation formula for the computation. Right. Start with the first example. And you can see it's very similar to what we already did. It's talking about a lottery. The lottery, it has a price that is 20-year annuity due with payment of 1,000 each July 1st. a payment of 2,000 each January 1st. If the payment are all left to accumulate in a new account, earning interest at annual effect interest rate of 5%. What is the accumulated value exactly 20 years from the time that this person won the lottery? So that was the plan. And you can look at July and January 1st. The payments are different. One is 1,000, one is 2,000. So then you have this plan that maybe the 1,000, there's 1,000 this July, 1,000 that July, 1,000 the other July. Consider all the July payment as one annuity. And consider the January 1st, another January 1st, another January 1st. Every January 1st, you get 2,000 payment. All those payments can be considered another annuity. Right, so then here is my timeline. So try to identify time zero. It happened on July 1st. That's the date when he won the lottery. So 20 years later will be another July 1st. So I call that time 20, July 1st. So start with July 1st and it was July 1st. So what was the payment? So he would get you can see every July 1st there's a payment. So you get July 1st on the time zero. July 1st on time 1, July 1st on time 2, and July 1st for this is the time 19. So because it's from 0 to 19, there's 20 payment of 1,000. Right, and there's 2,000 payment. The interest rate is 5%. So we want to find the total future value at time July 1st, time 20. So realize that this can be considered as two separate annuity. The one that paid 1,000, 1,000, 1,000. See, I'm using 1,000 times S double dot. S double dot is thinking them as annuity due, right? Because it's at the beginning of their time frame. This July 1st to that July 1st, that's 1,000 at the beginning. This 1,000 is at the beginning of the second time interval. So this January 1st is from this time to the January 1st on the 21st, that's when you get the future value. So, well, I was talking about July 1st, this July 1st to the compared to that July 1st. So that's kind of like the accumulated value for annuity due, right? So then the problem with this plan will be the 2,000 payment is on the January 1st. So if you're using 2,000 time double dot, that's calculated value the one unit time after the last payment. After the 2,000, you're ending that January 1st, 21st. That's actually half a year after the ending time. So you have to discount it back to the July 21st. That's why there is a multiplication 1.05 to the power of -1/2. It's a half a year time project back onto an earlier time. So that's why you have negative power. But those are the rest of the calculations. So the idea is you can use annuity due formula, the double dot S formula for calculating the total value. So the calculation is clear once we have a plan for the whole thing. So really we're using two separate annuity for the computation. That will be the first example for Super 7. That will be for today. Please go through your test 1 practice question. I already write down all the solution. I explained the process in the video. If you see any question that was incorrect or any like confusion from the solution, feel free to mention that on Thursday. Okay. So let me try to answer any question that you might have on the homework or on the test practice question. And we'll talk about it on Thursday, and the test will be given the next Tuesday. This will give us sufficient time for preparation. Okay. That will be for today. Thank you. Yes.
What do you mean you're not?
Yeah, 2 o'clock is fine. Hold on.
No. It's probably
Yeah, that's fine. It's fine.
because, I have you, and then 6.3.
Uh-huh.
And then I can push it.
Okay.
All right. Thank you.
See,
Quiz tomorrow is only over order statistics.
right, only over the 6.3.
Okay, so no.
There's no max. Yeah, not yet.
Okay, and